So let's talk about the properties of the dot product. We're going to let U, V, and W be vectors. Okay? And the letter C is a scalar. Here are 5 properties of dot products. 1, U dot V equals V dot U. So, dot product multiplication is commutative. Number 2, the 0 vector times our dot product with U equals 0. Now remember, the dot product of the 0 vector and vector U equals 0 as a scalar. All right, the third property of dot products is if I have vector U and I dot product it with V plus W, that is equal to U dot V plus U dot W. So, what we can say about that is that dot product multiplication is distributive. Here is a nice property as well, is V dot product with itself equals the magnitude of that vector squared. And lastly, I have scalar C times U dot V equals CU times our dot product with V, which also equals U dot product with C times V. So, what that says is scalar multiplication within dot products is also commutative. Those are the 5 properties of dot products. Now, use these dot product properties to help us in doing some calculations. So let's let U equal -1, 3, V equals 2, -4, and W equals 1, 2. I want to find U dot V and then times my W vector. So what I'm going to do is I am going to do U dot V first, which equals U dot V equals -1 times 2 plus 3 times -4. And that equals -2 minus 12, which equals negative 14. So now I have negative 14 times W, which is 1 comma 2. And that equals negative 14 comma negative 28. And that is U dot V times the W vector, which should make sense to us because U dot V is a scalar, and when I multiply a scalar times a vector, I get a vector. Letter B is U dot 2V. So that is 2 times U dot V. And I know from the first example, letter A, that that's 2 times negative 14, which equals negative 28. Easy peasy lemon squeezy.